All right, let's get started. Today, we are going to tackle the single most important first step in all of factoring, finding the greatest common factor, or as we call it, the GCF. Seriously, think of this as the master key that's going to unlock way more complex problems down the road.
So you guys are already pros at going forward. You know how to take factors and multiply them together to get a final expression. It's kind of like putting puzzle pieces together to see the whole picture. But what if we do the opposite? What if we start with the finished picture and want to figure out what the original pieces were? Well, that, my friends, is factoring. We're working backward to see how it was built.
Yeah, you can basically think of factoring as turning into a math detective. You're given the final answer, and your job is to work backward and find the original clues, the original building blocks. We're essentially just using the distributive property, but in reverse, to figure out what was multiplied together to begin with.
So, the very first clue every good detective looks for is the greatest common factor, the GCF. What is that exactly? Well, it's the largest possible piece, and that includes both numbers and variables, that every single term in an expression has in common. It's the one thing they all share.
Okay, so how do we actually find this GCF? I know it might seem a little tricky at first, but trust me, there's a really clear process we can follow every single time to get it right. Let's walk through it together, step by step. Here's the game plan. It's just 4 steps. First, you take the numbers, the coefficients, and break them down into their prime factors. You know, the smallest possible pieces. Then, you list everything out so you can literally see what they have in common. For step 3, you grab only the factors that show up in every single line. Finally, you just multiply those shared pieces back together, and boom, that's your GCF.
Let's actually see what this looks like. Take a look at these 3 terms here. Once we break them all down, the pattern just jumps out at you. See how a 3 is in every single line? And see how there's at least one x in every line? That's what they all share. So we pull out that common 3, pull out that common x, multiply them together, and we get our GCF, 3x.
Okay, so we figured out how to find the GCF. That's a huge step. But now for the fun part, actually using it. This is where we put it all together. We're going to combine finding the GCF with that whole reverse distributive property idea to factor the entire expression. Let's just jump into an example.
Let's kick things off with a nice, straightforward example, 4x plus 28. Our mission here is to pull out the greatest common factor from both of those terms.
So the first question you should always ask yourself is this. Just looking at the numbers, what's the absolute biggest number that divides evenly into both 4 and 28?
Yep, it's 4. No doubt about it. So 4 is our GCF. Now what do we do with it? Simple. We divide each of the original terms by that GCF. So 4x divided by 4 leaves us with just x. And 28 divided by 4 gives us 7.
And here is how we write the final answer. The GCF, our 4, goes on the outside of the parentheses. And on the inside, we just write what was left over, the x plus 7. Now here's the best part, and it's like a built-in safety net. You can always check your work. Just distribute that 4 back in. 4 times x is 4x. 4 times 7 is 28. We ended up exactly where we started. Perfect.
Okay, you ready to level up a little? What happens when the GCF isn't just a number, but it has a variable in it too? Let's try to factor 2x squared plus 8x.
Don't worry, the process is exactly the same. We just need to look at both the numbers and the variables. So, for the numbers, what's the GCF of 2 and 8? And for the variables, what's the most that x squared and a plain old x have in common?
Well, for the numbers 2 and 8, the GCF is obviously 2. Now for the variables. We have an x squared and an x. The simple rule is you always take the variable with the lowest exponent. In this case, that's just x. So our total GCF is 2x. Now, let's do what we did before and divide both original terms by that 2x.
So, same deal. Our GCF, 2x, goes on the outside. Inside the parentheses, we write what was left over, which is x plus 4. And of course, what do we do next? We run a quick check. 2x times x gives us 2x squared, and 2x times 4 gives us 8x. It's a perfect match. See, this process just works.
All right, let's look at one more super common situation you're going to run into. What happens when your expression, like this one with 3 terms, starts with a negative? There's a really helpful rule for this.
The rule is actually really simple, but it's super important, and trust me, it's going to make your life way easier down the road. It's this. If the very first term is negative, we just make our GCF negative 2. We pull that negative sign out, right along with everything else.
Okay, let's break this one down. The GCF of the numbers 9, 27, and 18 is 9. The lowest power of the variable is a squared. And because that first term is negative, our GCF is going to be negative 9a squared. Now, you have to watch the signs carefully when we divide. Negative divided by negative makes the first term a positive a cubed. Positive 27 divided by negative 9 makes the second term a negative 3a. And negative 18 divided by negative 9 makes the last term a positive 2. See that? Pulling out a negative GCF flips every single sign inside.
Okay, everybody, listen up. If there is only one thing you remember from this whole explainer, this has got to be it. This is the absolute golden rule of factoring.
I don't care what the polynomial looks like, I don't care how big or complicated it seems, the absolute number one, very first thing you should always do.
Look for and factor out the GCF. This isn't just like a friendly suggestion. It needs to be an automatic reflex. Checking for a GCF makes the problem simpler, and a lot of the time, it's the required first step before you can even think about doing any other kind of factoring.
So, to help make this process totally automatic for you, here is a simple little checklist you can run through every single time you need to factor anything. Think of it as your GCF game plan. Here we go. First, just ask, is there a GCF? Second, glance at that first term. If it's negative, your GCF is negative. Easy. Third, find that GCF and write it down. Fourth, divide every single term by it. Fifth, write your answer with the GCF out front and what's left inside the parentheses. And finally, number 6, the step you can never, ever skip, check your work by distributing. It's your personal guarantee that you nailed it.
So there you have it. You now have the foundational tool for all of factoring. The GCF is always step 1. But what happens if, after you pull out the GCF, you're still left with something like 4 terms inside those parentheses? I mean, how do you factor that? That's a great question, and it's exactly where we're going next.